The 44-minute signal, the mystery of pulsing star, ASKAP J1832. In March 2023, astronomers in Australia detected something that defies all known cosmic behavior, a signal from deep space that repeats every 22 minutes and lasts 55 seconds. Not once, not twice, but consistently, like the tick of a celestial clock. The source, a strange object named ASKAP J1832. But here's the twist. This signal continued for over 33 hours. That means it pulsed almost 200 times, perfectly on schedule. It's a signal unlike anything ever recorded. Is it a neutron star gone rogue? A magnetar with a mind of its own? Or could it be something we're not prepared to explain? This is the true strange. The story begins with the ASKAP radio telescope in Western Australia, one of the world's most sensitive instruments for detecting radio waves from space. Scientists were conducting a sky survey when they noticed something odd. A repeating signal. Radio pulses aren't unusual in themselves. We've been picking them up since the discovery of pulsars in 1967. But this one didn't match any known pattern. The object, later named ASKAP J1832 emitted a 55-second long pulse every 22 minutes. That interval is staggeringly slow for any known rotating neutron star, which typically spins multiple times per second. Even the slowest pulsars rotate every few seconds. But this? It was like hearing a heartbeat in deep space that refused to match the expected rhythm. And yet, there it was, pulsing every 13-20 seconds, as if it were keeping cosmic time. To understand just how strange this is, let's compare it to other cosmic phenomena. Most pulsars are rotating neutron stars, the incredibly dense remnants of exploded stars. These stars emit beams of electromagnetic radiation, and when those beams sweep across Earth, we detect them as pulses. But for a neutron star to pulse every 22 minutes, it would have to defy current models of astrophysics. According to our understanding, magnetic braking should slow down a neutron star over time, but not to this extent. The energy needed to keep broadcasting such a strong radio signal for 33 continuous hours is immense. Some scientists speculated it might be a magnetar, a neutron star with a magnetic field 1 trillion times stronger than Earth's. But again, magnetars are fast. They burn bright and burn out quickly. ASKAP J1832, it was persistent. And more eerie, it was on schedule. No irregularities, no signs of decay. That level of stability is highly unusual in cosmic terms. If it's not a typical pulsar or magnetar, then what is it? That's the question keeping astronomers up at night. One theory suggests that ASKAP J1832 might be a new class of ultra-long period magnetars, stars that pulse extremely slowly. Only a handful have been proposed, and even fewer observed. This would make it one of the slowest spinning neutron stars ever discovered. But that still doesn't explain its powerful signal. Another theory? White dwarf pulsars. These are rare and not well understood. A white dwarf is the burned-out core of a dead star, typically stable and silent. But under some conditions, it might emit pulses like a lighthouse in space. If ASKAP J1832 is one of these, it would be a first-of-its-kind discovery. And then there's the theory people whisper, but rarely say out loud. What if the signal isn't natural at all? Let's be clear. There is no direct evidence this is artificial. But scientists in the search for extraterrestrial intelligence, SETI, community haven't ruled it out. The precision and repetition of ASKAP J1832's pulses make it a curious candidate. After all, when the first pulsar was discovered, scientists initially labeled it LGM-1 for Little Green Men. It turned out to be natural, but the lesson remains. When we don't understand a signal, all options are on the table. The repeating stable pattern of ASKAP J1832 makes it stand out from typical background noise. Some have compared it to a cosmic beacon, a lighthouse from an unknown shore. Could it be a navigation system? A broadcast? A remnant of a long-dead civilization? We have no evidence for this, but the very fact that we can't explain the signal has left the door cracked open. This isn't the first strange radio signal from space. In 1977, the WOW signal stunned astronomers, a 72-second burst from deep space that never repeated. In 2007, scientists discovered fast radio bursts, FRBs, millisecond-long flashes that now number in the hundreds, some of which do repeat. And in 2020, a repeating signal from the galaxy M81 was found to recur every 16 days. But even among these anomalies, ASKAP J1832 is unique. The length of the pulses, the consistency, the sheer duration. It's like nothing else we see. Here at The True Strange, we don't jump to conclusions. We examine patterns, compare cases, and highlight what the facts actually say. What the data tells us about ASKAP J1832 is simple. It is real. It is persistent. It doesn't match any known category of star. That leaves us with a mystery in the sky. Not a ghost story, not a conspiracy, but a genuine scientific unknown. Something far beyond our atmosphere is ticking away like a cosmic grandfather clock. Whatever's out there, it's not shouting. It's whispering, repeating, almost waiting to be noticed. As of now, ASKAP J1832 has gone quiet. It stopped transmitting after March 2023, and it hasn't been heard from since. But its message, if it was a message, was loud enough to shake the world of astronomy. Maybe we'll hear it again. Maybe not. But when you look up at the night sky, remember, not every star is what it seems. Some of them keep secrets. Some of them break the rules. And some of them might be trying to tell us something. This is The True Strange. Subscribe for more real mysteries that remain unexplained. Do you think ASKAP J1832 is natural or something else? Let us know in the comments. And don't forget to like, share, and subscribe for more eerie truths that science hasn't caught up to yet.